Hi, this is a video reaching out to the Zig community. I'd like to try and give back in some way that I can. So for me personally, I've been working in game development for 10 years, and I've been mostly doing Unity development and branching out to other things like a little bit of Unreal integration, a little bit of web dev that has some game elements to it. But for the most part, I've been doing Unity. And then over the last 2 years, I've been working in Zig. So you can see my activity starting in 2023 was poking at Zig, and then in 2024 was very prodding at Zig, and then in 2025 was just machine gunning at Zig, doing some development. And over the last 2 years, I've learned a whole lot of stuff that I'd like to offer back and see what opinions about it are from the perspective of a game developer trying to make an actual game, and see what you think. So I'd like to thank Loris Crow for all the cool tutorials and Andrew Kelly for making the language and the whole Zig team for continuing development on it. I really respect the vision for the language and everything that's being done, the opinions that are being uh, thrown around, and the perspectives that are being applied to the language. I think it's really cool. Um, and the language I think is like very compatible with Gamedev. So I am working on a game. Let's start with that. I'm working on a game, and to an extent, the game itself is sort of like still in development. There's not too much to show for it. I will show stuff for it. But the final vision for the game is this, of basically driving a dirt bike through an authentic looking environment, um, and seeing how much of that experience I can capture, both in the environment and the effects being seen, as well as the experience of doing it with other people. And just working through the question of how you would do that, how you would design the game so that you're incentivizing people to stay together and to have places to go and things to do, as well as sort of like capturing the authentic nature of riding one of these dirt bikes. Um, and yeah, that no promises with that journey, of course. Like it's a very difficult thing to do. The environment is very beautiful, and the things that are happening are very interesting. The mud being thrown around the water, as well as like the dirt bike dynamics are really hard to capture. So that's been the objective. And this was a post I did from May. This is the game engine I'm building in Zig. And here it is running on Steam Deck. I got my Steam Deck right here. And so usually over the weekend when I'm done with my development, I'll be like checking it out on Steam Deck to see if it's still working. And it seems like, as you can see, like I'm getting 11 million polygons. They're not textured, but I can texture them without getting into like cutout graphics and things like that. And it still runs at 60 FPS and runs at like 12 watts on this demo. And a similar demo that I've done more recently, I've got it down to 10 watts at 60 FPS, or you can go up to 90 FPS at 14 watts, something like that. With the shadows and everything. So the shadows are trying to be static when they can, and if a chunk updates around the player or in the environment, like if something moves, then only that shadow chunk needs to update. So it's quite efficient. So that was a demo a while ago, and then I can show you what it looks like currently. There's some glitchy things going on. You have to see through some of the rough edges of it. Um, so for instance, the bike dynamics are still a work in progress, as well as the character itself is currently this little jiggly ragdoll guy. Woohoo! And the world is just a bunch of these spheres. Shadows are for the most part working, but need a cascade element, as well as the terrain needs cascading. The terrain needs textures. There's just tons and tons of work to do, and I've got a giant list of things to do. But for what I have, this is all written in Zig, and if I need models, I do it in Blender. So basically, Zig and Blender are my two dependencies. So I'm having fun with Zig Gamedev. That started with the build Zig, where I was showing off how I have just like a list of models, and I'm able to convert the Blender files into a format that I can read in. And there's some other things too as well that make Zig really fun for game dev for me. So the big major thing that was worrying me about Zig that I don't feel so worried about anymore is allocators. So for my case, I am running my entire game through this node graph, and each of the nodes receives some parameters, and for each one of those parameters, if they're not changed, then we can retrieve the cache of the previous result from that node and use that instead. And so this is a sort of reactive way to run the game, as well as each one of these nodes, the update loop for a node receives an arena. And so I can allocate on that arena and use it in a lot of different places. But you can see like I don't have any defer statements in my nodes because the arena manages the memory in the background. Basically, the node will fill up the arena with memory. You can even, when we go to the bottom, you can return data from the node that was allocated in the arena. But I basically have a guarantee that the arena will never clear until the next time that this node runs. So there's no need to like clear up memory in the meantime, and there's no need to worry about like if the memory is still valid, because as long as things are working consistently in the node graph, then the memory will always be valid, and the things that are provided out from this function will always be valid. The implementation to get that was pretty annoying, and it's a whole deep dive to be able to do that. But basically, each one of the nodes has a triple buffered arena that I just made pretty quickly, where it's 3 different arenas, and when you swap, then it will flip to the next arena and clear that to be able to fill it in. So if we go to the shadow node, we can actually retrieve not only the current data as input, but the last updates data as input as well. So each one of these nodes will execute a lot of the time, especially shadows. Shadows is executing a lot. But for instance, for meshes, they're only being, I'm retrieving only the difference in meshes. Where'd it go? Yeah, so I'm using the same algorithm for diffing that Git uses. I'm using here to diff the difference between the previous meshes and the current meshes to figure out which mesh has changed, so that shadows only update in areas where mesh data has changed or the instancing of that mesh data changes. So shadows are only doing the work that they need to by doing what feels like a naive solution to just like diff the input coming in from the current frame and the previous frame, which is possible to get that data because of using that triple buffered arena. Like it could be double buffered, but I needed a triple buffer to be able to trial out the execution of a node, and if it returns null early because it actually doesn't need to do work, then it can, then the third buffer is kind of just tossed out, and you can still have the 2 other buffers available for the current and the previous data. Cool. So allocation is sort of done in this perspective for game dev. I'm just allocating on arenas, and the arenas can get large, but they're not too large. Like on the Steam Deck demo, it was the entire RAM of the entire system was only at 3 gigabytes. The Steam Deck itself has 16 gigabytes, so we're fine. Like this is my target, the Steam Deck. So as long as we're in the target, then we're good. Lots of systems have 16 gigabytes of RAM these days, and so I'm not especially worried about it for game dev. Yeah, so let me show you some really cool stuff with calm time. Like Zig's killer feature for sure for game dev is calm time, as well as arenas. Arenas and calm time are both amazing. So for the mesh processing, for instance, I have this thing called a binary serializer. And this thing I just kind of spat out in a day, where it generically just takes a data structure, and if it's a struct, it serializes it one way, or an array, or a vector, or an optional, or a pointer. All these things can be handled at comp time. So basically what happens is that you can take in a oh, here we go. You can take in this blend mesh spec, which is just a struct of arrays of structs, and it will just serialize it for you into a binary file. So in this case, it's being written to a binary file. And then in order to deserialize it, it's the same process, and it's very simple. In Zig, the standard library includes a JSON serializer, and I'm sure there's probably a binary serializer either in the standard library or someone made it already, but yeah, for me it was like a single file to produce it as well, so it wasn't too much work. But it's really cool to be able to deserialize and serialize data based off of type definitions directly, instead of having to like write your own parsers and serializers by hand. That's an entire waste of time, and to be able to avoid it entirely is like awesome. So this binary serializer I use for file writing and reading, but I could also use it exactly the same for sending messages over the network. And the way that it's written in such a way that is hardware non-specific. So if you just like sent over the network a struct of arrays directly, then when it's received on the other end, the system could interpret it differently, could interpret the data differently. Like maybe they're binary optimized the types differently so that when it read it in, it was in different order or whatever. I'm not sure what the guarantees are, but that skips this process. Yeah, so that, that's one element of comp time. Of course, like comp time is used all over this project in various ways, but this is like a very obvious direct example of how comp time is beneficial. So yeah, like vector math as well, I've had a really good time with, only recently, as of I think Zig 14 when they introduced this. So if I go into like the rigid body code, there's a lot of vector math. And you can see like I have a case where you have a quaternion and you can convert it. You can call it on a method to get axis angle here. And this is, unfortunately, this is code that I've written. I think you could also get code that looks similar to this from Mach, the Mach code base. But I've written it here just because I've already gotten used to ZMath, and I was just creating a wrapper around ZMath. And so this code, though I've written it here, just wraps ZMath, who does the code itself. And so ZMath provides like proper floor-wide math that the CPU can directly just execute really quickly. You can do 4 operations at once. It's really fast. And then I have the wrapper to be able to just do method chaining on it. So you can do this normal method chaining. But what's really cool as well is that we have access to these Decl literals. And so here, I don't know if you've seen Decl literals for functions where you can call like init when it's an array list. But here, I'm also using it to sort of construct a quaternion using this relative. So given a target quaternion and the reference quaternion, what is the relative quaternion between them? And on its own, it looks a little weird. You could get the same effect by just taking the quat from here over to there, and that's the same. But on practice, I've always put in the type on this side because you can nest these things. And so you can have one of these Decl literal functions, and then in that you can also have another Decl literal function. So the same thing applies, where this is actually like a vec4 method. But you can just remove that type as long as the type that this function requests is known. Then you can just use a Decl literal here, which again like seems a little bit strange. Like why would you want to do this method when you could just take this here and drop it over to there. And that's actually the same code as well. This will compile. So the reason I'm doing it this way is that if you're doing dot chaining like this for math, it does work and it is kind of readable, but it's kind of not readable. This thing is operating with this thing, and that can or cannot be clear sometimes. But if they're nested together like this, they're in the same brackets. To me, it's more clear that these things are mathing against one another on the same level. And what gets really fun is like a lot of times with vector math and with 3D game dev, you end up in these scenarios where you're not quite sure, in the case of like a quaternion multiply or a matrix multiply, where one thing should be in front of another thing. So I'm not seeing a specific example here. Well, this is one right here, I suppose. So in this case, like maybe it's better. Well, this is a vector multiply, but we can pretend that this is a matrix multiply or quaternion multiply. Like the order matters whether or not this is in front of that one for a matrix or for a quaternion. They do like vastly different things. And there's people out there that can know exactly which one should be in front of the other thing logically, but a lot of the time it gets so abstract and confusing that you just don't know. And so you could have it where you have this like deeply nested expression and it looks a little bit all put together. But Zig format, once you hit save, will just break it all out, assuming that you add a comma to the last element of the parameter list. And from here, you can just start reordering things around. And so I could like reorder this entire thing as well. It's like, oh, I got the subtractions backwards. I could just flip that around really easily. And then when I'm done with that, if like I could keep it like this, all spread out, or I could compact it again. And that process is way, way faster than in any other language that I've experienced. Just that ability to unpack parameters into separate lines and then be able to shuffle things around. And also just for readability, it's amazing. So actually this Decl literals for math is really awesome. And I've been enjoying it like way, way more than any other language. Even languages that allow you to override the normal like multiply and subtract symbols, I don't enjoy nearly as much. Like trying to reorder the multiply between this total inverse mass and settings approach speed is annoying. Like you have to do this gymnastics. That's more work than it is to just to be like add a comma, reorder. Like it's that simple. So the less that you have to do for gymnastics to get this stuff to be able to be moved around and flipped around is awesome. So release mode is amazing. And you saw like it takes a bit to get a release build working. But once you do, the performance on it is awesome. Like, I can have 1,000,000 polygons in this demo currently, and it's running well. Like all the meshes are being processed quite well, everything. And you can see I've got my average frame rate here is really low because of that reactive model. It's only doing work on nodes only sometimes. And you can see it's running at 90 FPS, but if I wiggle around the mouse, then you can reach above 600 FPS. 1% and 0.1% highs are also really low. 60 milliseconds, it would be 60 FPS. 8 milliseconds would be 120 FPS. So the 0.1% lows are awesome, at least for my desktop. So, and that's in release fast mode. For normal development, I've been doing release small, assuming that I'm not looking for any sort of like safety issues. Really small just compiles a lot faster. So it takes roughly 6 seconds to get to a build and release small. And of course you can see that the performance is less, but it's still good enough that I can test. But one interesting thing that I found recently is that release safe is also really fast. Like release safe builds take a while to come out. They're probably the slowest of the builds to come out. But once you have one, it still runs like really well, and I'll have to see the 1% highs and 0.1% highs again. But you can get protection against going out of memory bounds on arrays, and you can get protection against other things. I'm not exactly sure all of what release safe does, but I'm surprised that release safe is still as fast as it is. We'll just wait for that to come out. Yeah, so in the release fast build, I was getting 5 milliseconds, 0.1% high, and now I'm getting 6.7 milliseconds, 1.1% high. So it's not too much cost to be able to have release safe. So when I provide this game to beta testers, I'll probably just give them release safe builds, because at least then it can catch bad memory errors more quickly, so that they can bring that back to me instead of just having some sort of weird memory corruption. It's not too much extra cost to provide that, and I can still do a release fast build when I finally release the game, when I'm done with all the testing and all the beta testing. So the release modes are really powerful. In Zig, I've found it like actually really nice to write my own custom systems. So here I've done my own physics for rigid bodies, and it works okay. Like I've got a tire collider that all it is just a for loop of for loops, where in each one of these cases I'm just like doing a raycast. So a tire shape is just made up of a bunch of lines shooting out from the radius from the axle, and that's how I'm doing physics currently with collision. And then for joints, I'm doing a PDB, position-based dynamics, where a whole bunch of these rigid bodies will just sort of like try and resolve themselves along the joints before figuring out like what the next velocity should be. And that really helps a lot with stability of both the ragdoll as well as the bike. And so writing custom systems in Zig is fine. It's a little fiddly, of course, to write your own physics engine. It's a little fiddly to write your own mesh deformers for characters and stuff like that, but it is possible to do, and we have a lot of resources out there to be able to do that stuff. And of course, Zig has compatibility with existing open source physics systems, like you could do Bullet with it, or you could do Havoc with it, I think. Like anything that has a C ABI, you could technically do, but for my game, I just wanted to do it all custom so that I knew how the dynamics work, because the physics is my gameplay, so I figure I should be writing the thing that is my gameplay directly, instead of having to like go through some sort of layer to be able to like finagle with it. So just directly doing it myself. So yeah, writing custom systems, totally good. Yeah, and I was showing a little bit of the build system. I have a bunch of these different models that I have cloth physics running in Blender for, and then during the export the cloth physics is baked out. This tube here is just a sort of collider to prevent the shirt from clipping through the backpack while doing the baked cloth physics. And then once it's in game, then you're left with costumes that don't clip against each other, and it's all just doing custom export through the build Zig script. That's really cool. Where basically I made my own build node that I just referenced. I just read the Zig standard library to figure out how this stuff works. My own build step I made, and then for each one of these files, it has to like go get the cache and the manifest and figure out if there's anything changed with the file, and if there is, then it runs everything underneath. If there isn't, then it will just continue, and it works for the most part. Like, and there's some times where the cache gets corrupted or something, and you have to just rebuild everything, but for the most part it works. And so I can run some export scripts from Blender using Python and convert that to a JSON format, and then convert the JSON format to a binary. And another cool thing too is that this mesh export step depends on this mesh processing executable already being built. So the build system is like building the JSON to binary converter and then running the export and then using the converter to convert the JSON exports to binary so that once they're finally packed into the final build, they're really fast. And you can see once I've actually built everything, this is my release fast build. So it's not as compact as it could be, but it runs really fast. And this is my resources. So this is all the binary files that I've packed embedded into this resource bundle. And then this is the node graph, and then this is the front end that does all the rendering and all the GLFW web GPU stuff. All these things are, the creation of these three things is managed through the build process. So it's a bunch of code to be able to do that, but then once it's done, and it's quite dependable and quite refactorable because this whole script is, of course, just Zig and has types that will restrict you from making stupid mistakes in your build system, and it allows you to refactor it sanely. One other cool thing I gotta show off with the export from Blender is that I'm also generating Zig files during the export process. So for instance, if I go to my bike and I rename something and say, now the mount to the handlebar is a different name, this will actually affect the resulting binary and will affect my compile step for all my code. So what I just got right there is a compile error for changing something about my art. And if this was Unity, you wouldn't get something like this at compile time. What you would do is when you run your game in Unity, you would be testing for 10 hours and be like, yep, it seems fine. And then you hand it over to a client, they play it and they say like, yeah, it's broken. Because what happens is if you don't explore all the possibilities of your game state while you're testing, then Unity could have snuck in a null ref because there's no longer an association between IDs in the art and IDs in the game. And so if you re-export your art or you change something about a prefab, then you could just accidentally break your game and you wouldn't know about it until very, very late, potentially. And so I know exactly now where I could fix this. And I actually get an inline compile error because I'm using Zig build check. That's a really cool thing once you get it figured out nicely. And potentially, I'm also getting autocomplete for this. So once you navigate to this file, you can see like it's an enum that I'm generating during build time, and this thing is now called left2. If you go back to here, we get completion for handlebar left2, which when it works is really fun. But the thing, of course, is that you at least get the compile time error for if you make a mistake. So that's really, really nice. I really enjoyed that. That's been something that I've been ruminating for like 4 years. I've been wanting to do this, and finally I have a language where I feel like it's really easy for me to accomplish this stuff. Okay. See, I was already showing off the no graph and the reactiveness, and multiple static libraries. And theoretically, with this resulting file, resulting build system, you could have these dynamic libraries be written in Zig, and potentially you could have a different front end written in C++ or something and just communicate to these. Currently, you're communicating to these over the C ABI anyway, so you could write C++ for a different framework and still call to the same game logic and same assets. The hope would be like if there's ever a console port, then I'd be able to like still use the existing like Xbox tools to be able to interface with my game as it exists in Zig. It may or may not be possible, like Xbox or PlayStation or Nintendo might want your game to entirely be in C++. So I have to figure that out if I ever get to that point. But that's why I've designed it this way, being able to like make a different executable and you just call into the game. That's still Zig. And the front end itself is it's over 1,000 lines, and it's kind of a mess. I'm not super proud of it. But you could rewrite this in a different language, and it would still work, theoretically. Okay, so on to some annoying things about Zig that make it really difficult for game dev. And the most obvious one is, of course, that the language is still in development. So currently, I'm on version 14.1. The latest version is 15.2, and version 0.16 is coming out soon. And I would like to upgrade to 0.15, but I can't unless I just want to spend a bunch of time to convert some things. Like I tried doing it and I got like a black screen. And so it, stuff changes with the libraries for Zig Gamedev that I'm using for web GPU. And I don't know what is up to sync. And I'm trying to do this game dev stuff now for a living, so I don't want to waste time just upgrading when it may or may not benefit me. So like 15 theoretically has better compile times, but I tested it a little bit and it was like, it's not significant enough to spend like 2 days or 3 days on this thing. So I just didn't want to deal with that if I didn't need to. And so at some point, I'll be incentivized to upgrade, and when I do, I'll be spending a bunch of time to do so. And I'm going to be praying that everything on the other end of it works out well, but there's a chance that I'll be in a hell for a while where I'm trying to get systems that used to work working again using the upgraded code. For the most part, upgrading has been fine up to this point, but I'm just holding off from upgrading until I have the incentive to actually upgrade. And yeah, it's a language in development. I appreciate all the development on it, but that's just a struggle that I have to deal with. Single math is really annoying. So I was showing off the vector math with Decl literals, but if you ever have to do single math, it's quite frustrating sometimes. So let me see if I can find some of that here. Generally, it's if you have like an as statement like this, then it's bad. Yeah, this is a perfect example. So this is a floating point number. This is a floating point number. And so in order for an integer to do math in floating points, I have to use float for mint. And so this I'm totally fine with. No problem here. But the thing that really, really frustrates me is that I have to wrap it in another function to say that this is supposed to be an F32. Like, I feel like somehow that should be implicitly figured out. And the fact that I have to do it is just insanely frustrating. I don't have to do this for the vector math because, like, if I have to convert from integer to a vector or a floating point vector, then I use something called from chord, and I can just do it like this. Just call from chord, and then the thing on the other side is a vec4. But I don't necessarily even need to write vec4 if the function receiving it knows what the type it wants is. So I actually really like how it looks here, and I really despise how it looks here with single math. And I don't know if this is fixable. It definitely got worse because it used to be that this type was in this function here, and I actually like that way more. This used to be fine. I was fine with this. But the fact that we went to this system is just so annoying. It's absolutely annoying. I hate looking at it. I was even tempted to just have like a very simple single math wrapper where I use the Decl literal kind of syntax, but just for singles and like wrap all the singles in a struct and everything. I tried it for a little bit. It was pretty nasty. So yeah, I got to that of like I really don't like looking at it, but I tolerate it because everything else about the language is super nice. Yeah, there's some ergonomic annoyances. So I have a lot of these try calls. I'm calling try everywhere, and wherever you have a try call, there's an arena on the other side of it. So it's this like weird symmetry where you pass an arena and you pass in a try, and that's just normal. And if you call try, then the function that calls it has to return an error, and I just do that. Like I'm not specifying what errors are being returned. I'm not trying to handle these things with any grace or anything. I'm just like being like, I don't know, an error comes out of this thing. So there's no nuance, and so it's kind of annoying that everything is just colored like that. It would kind of be nice if you just pass an arena and you don't have to try. And I've seen this being done with a voxel, like a Minecraft clone written in Zig. They made their own allocator, and they made their own array list and everything so that they didn't have to call try everywhere. And I kind of agree with that at this point. Like I'm sort of tired of writing try everywhere. Like it's just one extra thing to write. As well as like a lot of the time when I was starting, I was writing like standard debug, print, I, comma, dot, open bracket, close bracket, close bracket. Like this is already a lot. So I'm like trying to remove as much of this as I can. So I wrote my own debug, and then I just dump. Like if I'm doing debug, I just like dump grid bounds, and that's the method that I ended up using. It has its own formatting and stuff. Like that's what I need. And then if I want to like say something, then I just say it up here in debug log because I don't want to deal with all the ergonomic pain of like open close curly braces. Open close curly brace with a period is the least ergonomic thing to type on a keyboard ever. It looks great, but it's really tough to type. I'm like almost thinking like I need a new keyboard to be able to use this language sometimes, but I deal with it. It's slower. I would much more appreciate having no dot there or something. Like the dot there is, it's just like it's the finger gymnastics to be able to just type this thing. But I tolerate it, and ultimately the end result looks very readable, which is the decision being made with Zig is like to value readability over the ergonomics of actually creating the code to begin with. And the other thing I did for ergonomics to help myself is you'll see in the code that I just do like when I'm going to the standard library, I don't type in standard. Just one less thing to type. And if I need something new, like if I'm pulling in JSON, I'm calling stringify on it, is I actually like forked ZLS to be able to have a code action to import JSON from standard library. So it looks through the standard library and looks through your own project to find any symbols that match, and then if you accept the code action, then it just drops it up here and just says JSON is import standard.json. And so all this stuff up here, I didn't write it. I just had the code action auto-generate it, because like if I take this code and copy paste a section into another file, I don't want to deal with like writing this code by hand. It's very frustrating and annoying, but I don't want to like have all these extra namespaces for SCD in here. And if I like brought in all of debug, like I just don't want to deal with it necessarily. Like if I brought in all of utils Zig and then called utils.cord everywhere, like it's just too much typing when I'm actually just trying to get stuff done. So instead I'm saving myself a namespace and something dot to be able to just import it automatically using a code action, and I'm so much happier for it. It's a good fork, but of course it's a fork on like ZLS 14. So again, like I'm kind of locked in a little bit. Zig build check with LSP is really awesome. So to be able to, the LSP itself sometimes works, sometimes doesn't. But if I hit save, then I get like an error for this issue. And if I resolve the error, then the squiggly goes away. But Zig build checks can sometimes just fail randomly. And I got caught recently where if I did my export process during the Zig build check, it would actually fail because my export process was dumping a bunch of stuff to the standard out, which was like confusing ZLS somehow. So yeah, you have to have like no logging in your Zig build check besides whatever comes with the actual like compilation process. with Zig. And so most of the time it works, sometimes it doesn't, and then I just have to like quit out of everything and just restart, and then it works again. So that's been a little bit annoying, but I tolerate it because ZLS is the thing that's making me like working in Zig. If I didn't have ZLS, I would not work in Zig, basically. I don't like having to, write a bunch of code, do, and then eventually I go over and compile and see like one error, and then I fix that one error. Like, okay, go back, fix the error, come back, oh, there's another error, and then do that 20 times. It's much better if I can just like, I'm focused, I do a refactor, like instead of swing arm, now this is swing arm 2, I get a compile error. Oh, this thing is now swing arm 2. I get a compile error. This thing is now swing arm 2. Just way, way faster to be able to manage all that stuff if I have ZLS inline checking the compile step and providing me inline errors. It's the thing that keeps me from just using another language. Like, thank you so much, ZLS developers. Amazing. Yeah, and that's the whole of the Zig feedback that I've got. Super enjoy the language. I love the flexibility, love comp time. I love the type system. I love that I just get to use my own allocators and do allocation the way I want to, in a way that makes sense to me. And yeah, the ergonomics could be better, but I mean, it makes up for it for just like the freedom to be able to organize the code how it makes sense for me to organize it and refactor things like when it makes sense to refactor things. I don't feel like I'm locked into certain paradigms and things like that. Yeah, so for my own personal update, if you look at the channel, this channel has been around for, I don't know, 15 years, and I've been posting like hobby projects and everything, but finally I get to work on a game full-time, as far as I know. I'm going to be on Canadian employment insurance, which means I will be looking for work. I will be taking interviews and things like that, but I will be working on this project, and it's either going to be like a really awesome portfolio piece or it's going to be a completed game, and I'm hoping for the latter. And I'm doing that full time because, like, I mean, I think the game design is good. You know, just make this thing, make the thing, and it seems like if people hear the idea, they're like, yeah, looks good. I'm in Alberta, and I mean, I just tell people the idea, and they're like, oh yeah, sounds great. Like, when do I get to play it? So, as well as people online, they're like, hey, is that a dirt bike game? I'm like, oh yeah, it is. And they immediately get excited. So, which is it's a very exciting and rare experience as a developer, because a lot of the time, if you're building a 2D platformer, you're building a puzzle game, like nobody cares. But in this sense, like people are coming at the word work to be like, hey, the thing you're doing looks really cool. So uh, it's a really good sign for the engine that I'm building also is something that people get excited about. So this video, though there isn't too much to the game itself, got 1,000 views and got a lot of positive attention on the Steam Deck subreddit. And so it seems like there's a lot of anger against Unreal Engine from consumers. There's a lot of anger against Unity from developers. It's really the time to make custom game engines and to make really bespoke experiences with that stuff, if ever. So this was a great time transitioning from my job to be able to just go full into this, because I think like it's going to work. The tech, I think, is I'm confident in it. I'm not too worried about like things breaking underneath me. If I get stuck on Zig 0.14 for a long time, it's fine. Zig is fine as it stands in 0.14. Blender's fine, and those are my two dependencies, and I don't need anything else. So I got like the lazy shadow chunking. I've got the reactive node graph. I've got custom physics for the bike and rider. I've got this custom deformers to be able to get the baked cloth to never clip into costumes above and underneath. All this stuff is working, and every month as I keep continuing to work, it seems like I'm continuing to build like valuable tech on top of that. So this is the future for me. Hopefully for the next year, and hopefully within like 6 months, I'll have something that people can just take out of context and get really excited for. Um, yeah, and it's still going to be just a massive amount of work. So my head's going to be down. I'm going to be working on that. I'd love to talk more in the Zig community and the game dev community and stuff like that, but ultimately my first job is to make a really good game, and so that's going to be what I'm working on. I'm making my own art pipeline and everything, and game engine and game design, and so there's a lot of things happening in tandem. So there's not too much time to sort of hang out and socialize, unfortunately. But I'd love to contribute where I can. Uh, it would be nice to give back somewhat. And hopefully, once this game is out, I'll be able to give back more. But maybe I'll have a battle-tested game engine I'm willing to like piece out somewhat. But that's my update, and it's been a bit, and I'm happy that I'm able to just like continue working with this stuff, and yeah, hopefully you'll be able to see the results of that in the future in sometime in 2026. Thanks a lot for watching.